This part of the information universe delves into the nature of space-time itself at the smallest level. It will also demonstrate the effect of both gravity and motion on space-time and how they relate to each other. It will also demonstrate how both relate on quantum scales. The major problem with quantizing space-time to the actual Planck length and Planck time levels is the effects of length contraction and time dilation. That is, how can you have minimum units of space, time without an absolute time frame, which goes against the very concept of relativity. The key difference between the information universe and models such as string or loop theory is that consciousness plays a significant role. The pixelization effect is only rendered within the reference frame of conscious observers. God would also be a conscious observer, seeing the universe from his perspective. The first key to this solution is eliminating materialism, which by its very nature the information universe does. The second is making consciousness a key aspect dealing with the question. This combination not only allows for God as the supreme consciousness to have his own perspective, but for the perspective to be adjusted for the reference frame of any other conscious entity such as man. Concerning motion, no motion between Planck length units occurs until enough Planck time units pass for the object to cross the Planck length. It still follows what would technically be a straight path through these Planck units. On that scale, there is simply a pause along with angular movement resulting from the quantization. With gravity, individual Planck units remain flat like links in a chain, but the overall effect is still a curvature of space-time. The motion of space itself, in the direction of gravitational attraction, also does not move until the appropriate number of Planck time units is passed. This is what ultimately causes the gravitational attraction. However, because on this scale particles exist as waves of probability, they do not exactly move as described, but this does have an effect on space, time on this scale. It will also have an effect on gravity on the scale. However, because of the relative weakness of gravity, the resulting lumpiness has little effect. In conclusion, the information universe solves the biggest difficulty associated with the quantization of space-time. Observed relativistic relationships remain intact because the pixelization is observer-dependent. Furthermore, the inclusion of God as both the programmer and operator of the system provides a standard perspective for the processing. In the process, the information universe produces a way of describing gravity on the smallest of scales. While space-time is not inherently lumpy even at this scale, the waviness of particles does cause a jumbling effect. However, when you get up to macroscopic scales, this smooths out to the point where it has no effect. If you like this content, please support this channel by making a donation or buying a product through the links mentioned in the description.